breakdown the day before a test?
Usually I have a mental breakdown after I grade your test.
Oh, wow.
So that's where I need. That's where I need. So we oppose YouTube censorship. All right. That's where we
Your
are.
account's gonna be gone. I'm sorry. Your account's done. Your account's done.
No, I'm moving to another account so I can get another strike.
Yeah, you're gonna.
That'll be my first strike on this
You're
new
gonna start
account.
collecting strikes.
All right.
We should have a bet on how many strikes you get by the end of the year.
Yeah. Yeah. Well,
I'm betting 10.
like I said, the physics guide, the one strike says, oh, but we'll remove it in April if I keep my nose clean. Oh, well, thank you for telling me that, you know. But it is what it is. Let's go ahead and go through here, guys. This is a very, very, very important topic. So follow with me here. All right? Momentum. I want you to get this. Momentum is a key idea on not only the AP exam, all right, but, you know, it's a key idea on the AP exam, but I mean, for this chapter, but the AP exam, it's really, I guarantee it's somewhere, okay? Momentum is defined as mass times velocity. Impulse is defined as force times time. The impulse momentum theorem says this: change in mass times velocity is equal to force times time. Change in mass times velocity is equal to force times time. This is the impulse momentum theorem. Hopefully you can figure that out. Impulse, it's very, very important, okay? I want you to listen. Again, guys, I'm trying to teach to understanding so this makes sense, all right? Momentum, all right? Momentum, excuse me. The reason why I get like close to you because I put my foot up here and prop it. You okay?
Yep.
All right, let's see. Hand out. Yeah, we're 6 foot. All right. And so, momentum, mass is the measure of what? The measure of inertia. Okay? Momentum is really defined as inertia in motion. Mass times velocity. And really, did you know, and basically, momentum is, the units are kilogram meter per second. Okay? Momentum. We're going to see here a little bit later, the conservation of momentum states, we're going to see a little bit later, that the momentum before an accident is equal to the momentum after an accident. Okay? We're going to talk about that later, but I want you to catch this. So if you want to find the total momentum of an object, just take the mass in kilograms times the velocity. And that's simple. All right? If you want to find the impulse, how much for, like if I went up to Amira and I put her in the middle on a skateboard, because we'll get the skateboards. Are there 2 skateboards back there, David?
Yeah.
Are there 2? Okay. We'll get a couple of you. All right? But if I apply a force over time, I'm going to produce motion. Would you agree with that? That's impulse. What's the impulse? Impulse is not a really common one we use, but it is really heavy in the impulse momentum theorem. Okay? This is very, very, very important. So I want you to catch, let's go into our book. I really should. I should have turned that on. We're in chapter 7. Now, folks, listen. All right? Impulse momentum theorem. Okay? I want to look at example 1 of your book. So let's look on page 191. This is good stuff here, so follow with me here. All right. Now, here, look at this. Oh, by the way, remember, momentum is equal to impulse. If you find the impulse, it's the same as the momentum. You find the momentum, same as the impulse. All right? And this is really a good equation. Delta mv is equal to ft. And if you have a force times time, the area underneath force times time is impulse, but it's also momentum. Okay? Now watch this. A ball strikes a bat. Hits, bounces off. Initial velocity this way, applies a force, goes this way. All right? So they use J for impulse. And by the way, a Newton second is also a kilogram meter per second. Let me show you. Impulse, watch this. Impulse is a Newton times second. A Newton is what? A kilogram meter per second squared times a second. One of these cancels, what do you get? Kilogram meter per second. So it's the same thing, all right? So, moving right along, all right, Newton second. So moving right along, area underneath is important. And notice it changes direction. So we know this, they use P for momentum. I don't know, these are both on, do you guys anybody have your AP sheet out? Could you look to see if impulse is on there? They don't have example 1. Oh. All right, see if you can find impulse, MV, or FT. See if you find any of that.
I see them both.
Oh, good deal. All right, let me go to a blank screen. Okay, so we see both of those, guys. First, let me just say this: if they're both on there, you're going to for sure see momentum. It's going to be somewhere. Okay, it could be embedded inside of a. It could be embedded inside of a pre-response, or it actually could be a conservation momentum. What if I actually knew? I mean, without cheating and looking at the test, because that's dishonesty, I wouldn't do that. But if I really knew, I'd tell you what to focus on. It's a crapshoot for me. I look for trends to see, okay, this has been pretty consistent on most tests. I probably should push this. You know, when I gave you the Christmas assignment and the Thanksgiving, those were trends that were on there quite regularly, okay? So, let's look at example 1. And let's see here. Lloyd?
She's not here. She's fifth hour now.
Oh, me.
Oh, that Lloyd.
Yes. I'm here.
I can do that now. I got rid of her.
I think I
That's super.
I thought you meant fake.
And I had 2 Gabes. Gabe had 2 Gabes, 6th hour. Moved 1 to 1st hour. So I'd say, Gabe, I was like, oh, jeez. Like them both, but separated, like you both, but got you separated now. All right, so Gabe, will you read example 1 for me, please?
Oh, I do not have my book open.
Well, just go ahead and open it. We're on page 191. Need your book out. Sam, read it for me. I'm going to erase this. You already know this.
A baseball, mass is 6.14 kilograms, has an initial velocity of negative 38 meters per second.
What is it, negative 38 meters per second?
Yeah, as it approaches a bat. We have chosen the direction of approach as the negative direction.
Okay.
The bat applies an average force that is much larger than the weight of the ball, and the ball departs from the bat with a final velocity of 58 meters per second. Determine the impulse applied to the ball by the bat.
Okay, the impulse.
And
Okay, now watch. What is the impulse? Do we have force and time for impulse? What? Do I have force and time for impulse? I do know impulse is equal to momentum. So if I find momentum, is that impulse? Heck yeah! Watch this. I'm gonna just do this. Delta mv is equal to ft. This is momentum. This is impulse. I want to know this, but if I can find the change, so let's do this. Mass. Watch, and I'm gonna let you simmer. Your brain simmer. Final velocity is 58 minus a negative 38, and this is where some of you will miss this on your next exam. Ah, crap, I didn't mean to tell you that. I just gave you a hint. Something like this is on your next exam. I didn't mean to say that. Okay? No, I won't repeat it. It was only for those who are listening. Did anybody hear what I actually said?
No.
Oh, geez, I just recorded it on,
Oh, man.
on Censorship Central here. So that's YouTube, by the way. All right.
You're gonna, that's another strike. You're gonna have 5 by the end of the
No,
day.
I'm gonna have one, but it'll be on the new account. The problem is this one needs to be uploaded, because I'll probably, I have, no, everybody's here, 1, 2, 3, 4, 5, 6, 7, 8.
Isaiah.
Whoops, oop, oh geez, okay. I'll have to,
Edit that out.
all right, I'll send it later. Okay, what do we get for an answer here?
13.4.
What is it? I'm sorry. I didn't hear you.
It's 13.44.
I'm 13.44, and since it's impulse, I'm gonna say what? Newton times a second? What's the answer?
13.4
13.4, what are the units in the book?
kilogram times meters per second.
Okay. Is it the same thing?
Yeah.
It really is. It's probably a little bit better to have Newton times seconds, but you know what? I'm not gonna take off, it is exactly the same units. Okay? All right. All right, is there a B to this?
Yeah.
Next.
Assuming that the time of contact is 1.6 times 10 to the negative third seconds.
Okay, let me guess, 1.6 times 10 to the what?
Negative third seconds. Find the average force exerted on the ball by the bat.
Okay, 1.6 times 10 to the negative third. So force is equal to. So tell me what your force is.
$8,375 newtons.
8,000, what?
375.
375 newtons. 8,375 newtons. Check the answer, is that right?
Yeah.
Yeah.
Yeah. Guys, this is really interesting. I want you to see this right here. I want you to try derive a correlation here. This is very important because remember, bouncing and changing directions like this. Notice it's a minus minus and makes your velocity what? You're changing velocity what? High. Is that right? It's high. So, versus what if happened if the baseball, I know it sounds weird, bear with me, is stuck to the bat? What? Please help me. I mean, you got to go with me here. This is just critical. If you can grab this right here, we're pretty much done. But tell me, talk to me here. What do you think? What do you think would happen if the ball stuck to the bat? There was no final velocity. How does that affect the force? Let's think about this. This is an AP type question I'm posing to you. It would be lower. So in other words, bouncing creates what? More. Yeah. Which ultimately will create what? More force. So listen. Here's the deal. This is why, if you've ever been in a hailstorm, you ever been in a hailstorm? I have, like bigger hailstones, okay? Actually, during the summertime, everybody calls it sleet. It's not sleet, it's actually hail. Even like tiny, by definition, hail happens during the summertime. A lot of people say, well, it's sleeting outside. No, it's actually hailstones. They're just small. If you've ever been in a hailstorm that are big like that, those can hurt just a little bit. I was out there scraping fish one day years ago, and all of a sudden a storm came up in the backyard, and all of a sudden it started hailing and beating the tar out of me. So I kind of hurried up and got into cover while the bluegill had to wait, while I was cleaning them. But here's the deal. If I go out to your cars, I'll bet I could find a half a dozen of them. And if you'll look, I don't know if you've ever looked at that, if you look kind of at an angle with a sun, sometimes you can find tiny little dings in the hood or the top of the car, all right? And the reason for that is the hailstones hit. But a hailstone, which is going to cause more damage to your car, a hailstone hits smash or bouncing? Bouncing. This is why acorns can actually create dings. Not likely, but can. Or a walnut tree. Because a walnut gonna smash or are they gonna bounce?
No.
They're gonna bounce. In fact, if, I want you to think about this. Listen to what I'm saying here, because I'm going some here. If you have a hailstone hits at 50 miles per hour and smashes, the change in velocity is what there? 50. If it hits at 50 and bounces off at 50, what's the change in velocity there? 100. Twice as much force. Guys, you can go out there and, like I said, most of the time it's due to hail damage. You look at look at the hood of a car. I've seen some with bad hail damage. A lot of times you can't see hail damage, but if you look at an angle, you can kind of see a tiny, tiny, tiny dimple. Okay? But hail, especially if it's bouncing versus smashing, bouncing will create more damage. All right? Does that make sense what I'm talking about? Now, folks, all we're focused on today is momentum and impulse and the momentum impulse theorem, okay? Remember, Ft is equal to delta mv. Now, delta mv, your mass is going to stay the same, so it's what? M times what? Vf minus Vi? Final minus initial. I really want to kind of pound this into your head. Does it make sense what I am saying on that? Okay, so are we good? I think we're good. Are we good? Oh, good. Okay, so what I'm going to do is cut you loose on the homework. I'm keeping it simple because we're going to be doing some demos. You guys are going to have to fit on I'm going to have to take the heaviest person and the lightest person here. And me being the heaviest, I'm not going to sit down there. I'm too old for that. Once I sit down, I'm probably not going to be able to get up.
Oh, man.
So moving right along, here's what I'm going to give you. Please write this down. 1 through 9. And 12. 1 through 9 and 12. This is chapter number 7. I want you to start. We're going to do this low and slow. Your test is not going to be for a while, all right? But we're doing this low and slow. We're going to get back to doing some practice AP. Let's get our brains thinking, okay? All right, any questions before I shut off from Censorship Central? That's the new name of YouTube.
Oh.
I'm going to see if they'll ban this one. If they do, then you know you got a problem.
They might demonetize this time.
Yeah, like I was getting money off of this. I wasn't. All right, we good?